Okay, here we go. Now I'm going to go ahead and give you what I thought I would find, the evidence of what I've read before that describes the construct of the leap year, okay? Which is in a sense, but not exactly, because the days are not 365, they're 366. And then there's 1 through 65, but let's read it, okay? The exact data. So this is a correction, okay? In synopsis. In the Gregorian calendar, the standard calendar in most of the world, most years that are multiples of 4 are leap years. In each leap year, the month of February has 29 days instead of 28. Adding one extra day in the calendar every 4 years compensates for the fact that a period of 365 days is shorter than a tropical year by, once again, 6 hours. And it's not an exact 6-hour data read, as you'll find out. Some exceptions to this basic rule are required since the durations of a tropical year is slightly less than 365.25 days. So once again, it's not quite a quarter day, which makes it lengthen, and you'll find that it's actually a 400-year cycle of the leap year. The Gregorian reform modified the Julian calendar scheme of leap years as follows. Every year that is exactly divisible by 4 is a leap year, once again, except for years that are exactly divisible by 100. But these centurial years are leap years if they are exactly divisible by 400. For example, the years 1700, 1800, and 1900 are not leap years, but the years 1600 and 2000 are. Okay, once again, that's why Y2K seems to be an issue because of the data and the connection. It was such a concern, okay, for whatever reasons. Over a period of 4 centuries, it was one of the many reasons why Y2K was a big deal, because everyone was so concerned about their data and all this other stuff going into the year 2000, if you remember, if you were around. Over a period of 4 centuries, the accumulated error of adding a leap day every 4 years amounts to about 3 extra days. The Gregorian calendar therefore omits 3 leap days every 400 years, which is the length of its leap cycle. This is done by omitting February 29th in the 3 century years, multiples of 100 that are not multiples of 400. The years 2000 and 2400 are leap years, but not 1700, 1800, 1900, 2100, 2200, and 2300. By this rule, an entire leap cycle is 400 years, which total 146,097 days, 146,097 days, and the average number of days per year is 365, once again, plus 1/4, minus 1/100th plus 1/400th equals 365 plus 97 over 400 equals 365 point, once again, 2425. So it's literally 0.0075 less than a quarter. Okay, you see this? I don't know if you can understand the science of it, but if you subtract 0.2425 from 0.2500, you will get 0.0075. Okay, so it is an extremely minimal number. I think that would be 75 ten thousandths is what we would say. 75 ten thousandths. Okay, the rule can be applied to years before the Gregorian reform, the proleptic Gregorian calendar, and before the year 1 if astronomical year numbering is used. Okay, so once again, this is a deeper discussion and explanation of a comparison with the 364 days of the beginning creation. And if I'm not mistaken, the reason is because there was a cataclysm in the beginning. Okay, and if I'm not mistaken, after our departure from the Milky Way, as I discussed, when the Milky Way had its cataclysm, we had secondary, at least one more cataclysm. Okay, so I'm going to stop now and continue.